Hey Mathorians, welcome back to Mathora. Have you ever wondered how to differentiate complex functions like sine x squared or e to the power of x to the power of 3? Well, today we are going to make that super easy with the chain rule. Let's jump right into it. So, why is the chain rule so important? The chain rule is like a secret weapon for differentiating composite functions. A composite function is just one function inside another, like fx equals sine x to the power of 2, where the sine function is applied to x to the power of 2. Without the chain rule, differentiating these would be a nightmare. But with the chain rule, you can differentiate them quickly and accurately. It's like breaking down a complex puzzle into smaller, manageable pieces. Here's how the chain rule works. If you have a composite function like fx equals g inside the function hx another function, the derivative is f dash x equals g dash inside the brackets hx times h dash x. Right? Sounds a bit tricky, right? But let me break it down for you. First, differentiate the outer function. That means the g function, right? So, but leave the inner function hx alone. Then differentiate the inner function hx normally. Finally, multiply the two derivatives together. It's that simple, right? So let's look at a simple example like fx equals sine inside the brackets x to the power of 2. Here, the outer function is sine u, as we can assume x to the power of 2 equals u. So we can write it like this: fx equals sine u. So as you all know, first we need to find the derivative of sine u. So sine u means f dash x equals cos u times, then you need to find the derivative of the inner function. That means derivative of u, that will be u dash. So as we all know, cos u means we can simply write it as back again like u means x to the power of 2 times u dash. The derivative of x to the power of 2 is 2 times x. So the answer will be 2 times cos x squared times x. Boom. That's the derivative. Notice how we differentiated the outer function first, then the inner function, and multiplied them together. So let's make it a bit more complex. How about fx equals e to the power of x to the power of 3, right? So we need to write it back again like this. Fx equals e to the power of x to the power of 3, right? As we all know, we can simply assume x to the power of 3 as u. Then we can rewrite the formula as it is like fx equals e to the power of u. Now it is pretty easy to solve, right? So if you want to differentiate the fx formula, then f dash x, I'm sorry, f dash x will be e to the power of u, derivative of e to the power of u means e to the power of u multiplied by u dash. So as we all know, e to the power of u. So here u means x to the power of 3 times u dash. That means the derivative of x to the power of 3. That will be 3 times x to the power of 2. So the final answer will be 3 times x to the power of 2 times e to the power of x to the power of 3. Look at that. Again, we differentiate the outer function first, then the inner function, and multiply them together. The chain rule works like a charm. Okay, let's finish with a fun one. Fx equals like this way. Fx equals cos x to the power of 2 plus 1. Okay, so we can assume this one as u. So the outer function is cos u. Out is cos u. Inner is x to the power of 2 plus 1. That means simply u. So the derivative of cos u, like we can write it like this, f dash x, the derivative of cos u is negative sine u, and we leave the u as it is. The derivative of u, that means x to the power of 2 plus 1, is 2x. So apply the chain rule, we can write like this, as we need to write it like this, u dash. So negative sign. Now we can again use the uh, original values. I mean, we were using x to the power of 2 plus 1 as u. So now you can write it back again like x to the power of 2 plus 1 times the derivative of u dash. That means x to the power of 2 plus 1 is 2x. So the answer is, always try to solve the question into the most simplest form and keep to try it very neat. So that's a good way to deal with calculus and everything that you are going to do. Neatness is always the first. So you can write it like 2 times x times sine x to the power of 2 plus 1. See how quickly we differentiated a trigonometric function with an inner expression. The chain rule handles it all. And that's the chain rule in a nutshell. It's the key to differentiating composite functions inside other functions. Just remember, differentiate the outer function, keep the inner function as it is, and then multiply by the derivative of the inner function. It's that simple. If you found this video helpful, don't forget to hit that like button and subscribe for more awesome math tutorials. Next up, we are going to tackle implicit differentiation. So stay tuned, keep practicing, and remember, math is all about breaking things down step by step. Okay then, bye bye, see you.